Welcome, welcome. I am Jeffrey Palermo, and I'm the Chief Architect of ClearMeasure, and we are a software architecture company focusing on empowering Microsoft platform custom development teams and increasing the level of software delivery capability. We know that so many companies want to have high-performing teams in-house, and that's our focus in helping your team be self-sufficient and able to move faster, deliver quality, and run your software systems with confidence. So I'm excited. We have a great group here for this webinar, and it's a really important topic. And over the last over 2 decades of working with custom software, I have seen just scores of modernization projects, and I know the challenge that an aging system poses. And so today, I'm going to show you a faster path to software modernization, regardless of which of the three major strategies you choose. Now, I know how busy you are, and my goal is to get you out of here in about a little over 30 minutes. We don't need a full hour here, 'cause I know you're really busy. And so let's get started. Let's get started and dive right into it. Um, Now, for today's webinar, logistically, you can chat amongst yourselves using the chat window. We'll send out some resources there, and um, you can ask a question in the Q&A window. I'll make sure that all questions are answered. I'm pretty good about working in those in line with the content, but if there is any question, I won't close the webinar until all the questions are answered. I want to make sure that that's there. That's why you're here live. Now, if you have a coworker who wasn't able to make it, because you registered for the webinar, you will receive the recording, and feel free to share that with a coworker. Now, we're going to talk about the challenge of aging software and why we find ourselves in need of a modernization. And then we're going to explore some symptoms of an aging system. Then we'll look at the overall roadmap of how to plan your modernization, including the available strategies. The details of each strategy we'll go through, and then we'll share some of the value that we've provided that may be helpful. And at the end, we'll give you some contact information and resources that can be of assistance to you with your modernization initiative. Now, I want to give you something of value, because whether it's modernizing an old system um, or you're starting on a new project with the new system, you need a automated DevOps environment. You need a modern way of moving fast. And so at ClearMeasure, we've helped thousands of professionals across over 40 different countries be better at software. And my latest book, .NET DevOps for Azure, it exposes the secret about how any team can have a fully automated DevOps pipeline for any application, new or old, by following a concrete 7-stage design. So here's what you need to do. Step one, read my book. By the way, I'll give you a free ebook copy just for being here today on the webinar. So either use the link in the chat to request that ebook, and we'll get it to you. And now, this offer actually extends even whether you're watching live or if you're just catching this recording. And step two, read the book and understand the 7 stages of a DevOps pipeline. And then third, launch your own .NET DevOps pipeline. You can use our public project as a model that is in the book, and you can adapt it to your existing application. There's lots of people that have used this in order to get your existing legacy system into a modern and automated DevOps environment. Because if you do this, you will have a fully automated DevOps pipeline, whether it's on-premise in your own data center or whether in Azure, and that will enable you to move faster and with higher quality. Another resource you might be interested in is a podcast that I host. It's called the Azure DevOps Podcast. It is for people shipping software with Microsoft technologies. And it is DevOps. Essentially, the whole theme of DevOps is being really good at shipping software, and we focus on all things Microsoft. So you want to go there for past episodes and show notes. We have just a wealth of a wealth of information. Great crop of guests. Now, let's get into the challenge that we're facing here. The reason why you have chosen to come to this webinar, and this is always one of my popular topics. So I'm not surprised at just the tremendous group that we have on this webinar, because this is always one of our highest registration webinar. We always have a really large crowd. Um, but we all have systems that have been around for a long time. You might call it a legacy system or not, but a system that is showing its age is not resilient to change any longer. And when it goes down or has stability issues, there's business disruptions that occur. And these systems are important. These systems are no longer able to change at the pace or in the way that is necessary for your organization to execute its go forward strategy. And when the software system starts holding your business back, you have to address it. So let's dive into the problem a bit. All right, level set. We have an aging system. We call it a legacy system. It could be an old platform, and certainly COBOL mainframe systems are called legacy systems, but there's a lot of our clients doing fresh development in what you would call non-modern systems, and they're doing it well. So platform alone doesn't make a legacy system. We encounter people who need to replace their systems, and it was built in .NET. It was because of the architecture or some other things. Now, I mentioned the platform to illustrate that the older platform alone doesn't cause a system to be the root cause for business delays. But an old platform may be a symptom that you're seeing. This system may be mentioned in meetings, and people may have called to redevelop or replace the system. Your managers may be reporting problems retaining developers or recruiting new ones who don't want to work on the older technology. And those candidates may be opting for other companies when they learn about the software system they would be working with. And also, you might be experiencing stability problems in production, or changing the system. If changing something breaks a different, seemingly unrelated part of the system, your staff will then become hesitant and fearful to make changes. And these are all symptoms that we see, but there could be root causes lying under the surface. And the three that we see over and over and over again, which are hiding under the surface, are around maintenance, when it comes to being able to move fast with that system. When it comes to recruiting, we see that perceived lack of opportunity. But a lot of times when it comes to being able to change the system and being able to move fast with it, there is an insufficient development environment. And that one is, I would say, pervasive. And so I want to call your attention to that specifically. Now, there are 3 strategies that you can choose for modernization. Every path that you can take is going to fit into one of these 3 strategies. So the 3 strategies for modernizing an application are: 1, package replacement; 2, rewrite, custom; or 3, fix and upgrade. Regardless of the shades of gray, these are the 3. Now, we'll ignore a 4th option, which is not a strategy, and that is to do nothing and wait out the problem. But that's not a strategy. You're not actually solving the problem. Now, each of these has some benefits and some drawbacks. The package strategy, those package vendors like Salesforce or Force.com, and a lot of others, they promise to be the quickest to get to a full replacement, but it's still not quick or cheap. We're talking about 7-figure budgets for any of these. But the package sellers are going to tout faster timelines than a full custom rewrite. You could rewrite in modern technologies like C# and Azure as the second strategy, or you could fix the problems you are having with the system and carry it forward. Now, that 3rd strategy, fix the problems you have and carry it forward, that 3rd strategy seems far-fetched. You're looking at the first 2 strategies because your people have tried to fix and upgrade these things for years. And so, you still find yourself with a system that's resistant to change. So strategies 1 and 2, they look promising, don't they? But think about the duration. The duration you have to wait until real usage, until initial cutover, that's a problem. If you can't change your system and you're going for strategy 1 or 2, and then you have to replace it, Well, now you have a risky cutover event down the road, 18 months to several years for large systems. And that's problematic because your business just can't do nothing for 18 months. These are big, significant systems. So we need to dive in a little bit more. Let's figure out how to see some value quicker. And if we can, if we can segment the system and do some interim releases, then we can capture value quicker. Now, there's a better way to execute any of these, the first two strategies. But if we are going to have a release, let's just say the package replacement, or we're replacing a segment of the system. But if we're going to do uh, a release where some of the new and some of the old are in place, then we still have to be able to change and refactor our existing system. So you got to realize that regardless of the modernization strategy, you have to regain enough control over the system that you have. Otherwise, we're going to commission a long and expensive project. We're going to set up a highly risky big bang cutover event. And we all know those types of projects just love to fail, those big bang cutovers. And so I'm not here to sell you on a strategy. Each of these are fine. You can pick one, doesn't matter. Any of these are viable. But I want you to know that even though you have that aging legacy system that's hard to change, that nobody wants to touch, you have to do what is necessary to regain control over it. And if you don't, you're sunk. Even if you think you're rewriting it, you have to be able to do things in incremental chunks. And so you have to be able to modify what you have and re-release what you have. Now let's talk about how to regain control. It's more than just having a way to execute changes uh, and make changes and use Scrum. Now this change cycle on the screen probably looks familiar to you, and it's part of our curriculum, and it revolves around a way to build and deploy software. And you have plan, code, integrate, package, release, operate, learn. But it's woefully incomplete. You can't just say, oh, we're going to do this and then have it magically happen. You need to focus on some capabilities of the team. So to execute our modernization, we're going to regain control over our existing system. And we have a model for that. Regardless if your system is an older platform or whether it's just an older version of .NET or a modern platform, but it's gotten out of control because it's been poorly designed, or maybe it's a system that you inherited, you need to be able to change it. Now, the center of our model is the foundational infrastructure that's necessary to make changes and redeploy them. But there are other layers of capability that are needed as well. And you'll use these to regain control of the system during the entire modernization as you make some fairly significant architectural transitions. And I put this automated DevOps pipeline at the center. Everything revolves around it, and it's a base capability, but I make it small because it is just a piece and it is just a foundation. And you need to have the 7 key stages of your automated DevOps pipeline. You need to have your private integration build with your multiple levels of test automation and static analysis. You need to have repeatable release candidate packaging and archiving. You need to have a test automation environment deployment with running a full system test. You need to have a manual test or multiple manual test environments. You need to have your production deployment. You need to have your monitoring and data warehouse level telemetry. Um, and you need to have a way so that you have a built-in system health check and a way to measure your individual cycle times from your coding cycle to your team's build cycle to your product management's testing cycle. You need all those things, but that's not enough. That's just the beginning. And there's been so much focus on the industry about automating the builds and CI/CD, and well, it's all great, but you can't stop. There's so much more, and especially in a modernization scenario, you have a lot of technical debt, and you need to think about it the right way because you can't fix everything right away. You can't boil the ocean. So let's talk about these different layers of capabilities. Uh, of each of these layers, each of them must have a sound strategy, be executed with discipline, and have objective measures. And before we move on, I do want to show you just and provide an offer for a free drop-in out-of-the-box architecture for your automated DevOps pipeline. Um, you absolutely must have one of these for every application you manage, aging or not. And not having one of these almost guarantees that it'll show its age as soon as the original developers leave the team or leave the company. And so what you see on the screen is part of a larger design poster, about a third of it. This is the top third. And if you post in the chat or follow up afterwards, use the link in the chat. We're happy to send and give you this DevOps poster to have. It's a full-size PDF. It's formatted for Architecture D paper, so you can print it on a plotter and hang it up in your office if you like. This is highly shrunken, but it's a technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps Services and Octopus Deploy. It has a continuous integration build, a 3-tier deployment pipeline. By the way, you'll never have fewer than 3 environments in your deployment pipeline. Even for simple applications or microservices, we've done some other webinars that dive deeper into some of these technical details. And please reach out if you need more information on this in particular, or how to set up a system. We do tons of DevOps implementations. We do tons of our 30-point DevOps inspection to inspect and find gaps in what you have implemented now. We also do plenty of database DevOps with Redgate SQL change automation. And that is just as important, not just the front end of the application. You need to deploy your database changes with your application changes. So again, no matter if your system is a really old platform or just an aging design, your environment starts with this basic capability to move changes through. And you'll continue to have a very hard time making any changes to your legacy system without this basic infrastructure. And again, even for older .NET systems, we have .NET framework templates, and we have ways to adapt other technologies and application types. Every application that a client has brought to us, we've been able to adapt into this general structure and make it work so that the build and deploy and then quality controls that are added in along the way are automated. So it's super important. Now, let's dive into the first layer of our team capability in order to gain full control of your software system. There's many practices available to you. There's many that have been labeled best, but there are some particularly useful ones in a modernization. Now, again, you can't say you're using best practices because there are so many of them that it is logistically impossible to use every best practice in a particular project. So the strategies, you have to make a choice and say, these are the practices that we're using, because no one uses them all. There's some that overlap and it's an either or decision. So you have to choose, but there's 3 that I want to highlight that are of particular usefulness in a modernization. The first one is feature branching, and that is making small changes and redeploying frequently. And so if you've heard of the term trunk-based development, that is the practice of making every change on a very short-lived feature branch and integrating very, very frequently with the trunk or master, the mainline branch. Which, by the way, unless you're developing completely by yourself, you'll never not use branching if you're using Git source control. It was just built for branching. And when you couple that with an automated DevOps process, the branching really makes it come alive. So that's feature branching. You want to use feature branching because you're going to accidentally destabilize that system, and you need a safe place to do that. The second is refactoring. That is the practice of improving the structure of the existing code without changing its behavior. And there's a Martin Fowler book on refactoring that's over 10 years old, maybe 15 years old, but it is fantastic. You definitely want to employ refactoring, making sure that you improve the structure without changing its behavior. And there's techniques to do that, which most people make the mistake of just going in and making a change. Then they accidentally change the behavior, which is not the intent because they're not doing it properly. The third practice I want to highlight is continuous integration. Even if you have difficulty putting a full DevOps pipeline in place, if you can at least quickly get to the point where you can continuously integrate changes from various people so that no single change is large. You at least need your build, a few test suites, and at least one deployment to a pre-production environment. That gets you the continuous integration process. Okay, I want to remind some people. Some people have some people who've only been in the industry less than 10 years are trying to redefine, not trying, they're accidentally redefining continuous integration to be just an automatically triggered build. Continuous integration came about in the early 2000s. There was a book written about it in 2006, and the continuous integration process goes all the way to the first time you deploy to a non-production environment. Okay, and that's how you know that you've integrated the changes from multiple people, is that the software system still builds and deploys and can start up successfully. If you don't know if it will deploy and start up, then you have not yet finished integrating changes from multiple people. So if you're not aware of that book from 2006, it's literally called Continuous Integration. It's published by Addison Wesley. You can find it anywhere books are sold. Way back in 2006. So we do find people that are saying, "Hey, we have continuous integration in place," but all they have is an automatically triggered build, which is a part of continuous integration, but it's not continuously integrating. So take a look at that if you might have a gap there. Now, there's the next layer, defect removal. There are going to be big changes during your modernization, and we need to be able to find defects. So you want to start with full system testing. If you have no automated tests in place, do not start with unit testing. Okay, this is the reverse of test-driven development. If you're starting a brand new code base, test-driven development is the way to go. You write code, you write unit tests with the code, and then you layer on component level integration tests, and then you layer on full system testing from the outside in with Selenium, Cucumber, or Appium, whatever test framework is appropriate for the technology stack. But with a legacy system with no automated tests, you can't start with unit tests. It wasn't designed with that decoupling in mind. So you want to reverse that and start with the full system testing from the outside in, scenario-based testing. That is going to give you the safety net, and that is going to give you a broad covering to be able to be bolder and bolder about refactoring. Next, you want to do formal recorded manual regression tests, and there's plenty of tools to allow you to do that. Azure Test Plans allows you to do that. Because you're doing a lot of manual testing, you want to keep records of when those manual tests are being captured, and automatic recording of screencast video and whatnot. And so you want to use a high class testing tracking tool for that, because the reality, even though you would love to be fully covered with automated tests, you're not. You still have to rely on manual testing. So you want to put some formality into there as you start transitioning some of those regression test cases from manual execution to automated execution. Then finally, with each refactoring, with each change, if you're going to replace a certain section of the application, if you're doing strategy 1 or strategy 2, and you're going to take a certain section of the system offline, you need to adapt it with whatever's replacing it. You need a definition of done. With each of those refactorings, you want covering tests to be run and any other checks to help keep you safe. It's important to have a definition of done. Now, let's talk about workflow. You're getting back in control of your system. Every one of you is probably using some type of Kanban style board to track your work, whether it's just 3 columns of not started, in progress, done, whether you're using Azure boards, Jira, or even Trello. All these tools represent the work in a series of columns. If you want to add extra columns to your Kanban board, an example when you're going to want to add at the very beginning is, you might call it understand user scenarios. With a legacy system, there's guaranteed to be scenarios that you don't understand. The system's been around for so long, you don't know everything that it does. And so there needs to be specific time dedicated to understanding the scenarios. And when you add a column, that gives you the opportunity to take a needed change, take that card, that issue, and put it in the column so that everybody knows, hey, yeah, we're spending time, and what are we doing with this thing? Well, to start, we're understanding how this works and understanding the scenarios around this part of the system. Another column you might add could be add covering tests, so that before you even start changing the production code, you are adding your safety net in that area of the application to keep you safe. And by putting the card in a column that's clearly marked with what you're actually doing, it's going to enable your project managers to know what's happening and be able to manage the project, because we're actually representing the real work that's really happening instead of just an in progress column. And the only thing management can ask is, hey, why is this taking so long? Well, it may be in progress, but if you're doing 3, 4, or 5 things, well, we're not really giving any answers. So if we can take those 3, 4, or 5 things and make dedicated columns, well, now we've shed light on our process and are actually enabling our project managers or executive sponsors to know what's happening and know the real nature of the work. Now, if you have had staff turnover, then your people likely won't be expert power users of the system. Um, it's really important just to call that out and recognize that um, as you're planning the project. Okay. You might want to talk with actual users and screen share, record them demonstrating how to use the system for some common tasks they perform daily. So pull them in. All right. Next layer is architecture blueprints. Now, the 4+1 view model, the software architecture, was written about in 1995 by Philippe Khrushchev from Rational Software Corporation. It's probably the best emergent iterative architecture blueprint model still to this day, and we use it here at ClearMeasure. And it calls for 4 different layers: the runtime layer, logical layer, process layer, and development layer, of different ways to look at the shape of a software system and create blueprints. And then the +1 are these system's capabilities, so that we understand what the capabilities are. And if we're gonna modify the shape of the system, the architecture of the system in a modernization project, well, we need to know what the shape is and make sure we don't have any misunderstandings. And we need the whole team to be aligned on the shape. So you want to update your architecture diagrams and upgrade them to a 4+1 level. And this is how you create a new revision of those architecture blueprints, and you're casting a future vision for what the system will look like when finished with this particular increment, with this particular change. And so you want to draft that transitional architecture, and at each of the milestones that you go through, whether you're replacing the whole system a big chunk at a time, or regardless of what strategy you've chosen, you want each milestone to have an updated architecture blueprint set. So you use this to align the team and also to inspect what is changing. Now, one of the replacement patterns is the strangler pattern. If you've never heard of it, look it up. Literally the strangler pattern, like named for strangler. Now, in this pattern, you refactor parts of the system to disconnect a certain section and essentially make it dead code, take it offline. And then you just leave the code in the code base, but it is dormant. It is completely disconnected from every place that it was connected. And now you connect it to a replacement. And so you essentially strangle it by cutting it off, and then you leave that code there dormant, because in a lot of cases, leaving dead code there is going to be a less stabilizing event than going in and deleting a whole bunch of stuff, and then you realize, oh shoot, how did I break this? So strangler pattern is something you can do. Now, I want to stress architecture blueprints. Every professional that builds something uses design drawings and design models in the communication of what you have, what you're building, what you're changing. And teams that lack this are constantly struggling to put the same image in the minds of the team members. Okay, so it's really, really important. Now, next layer is operations, how you're running this system. You want to assess, for this legacy system, you want to assess the state of your logs and the observability characteristics of your existing system. You want to add more telemetry, and you want to provision a centralized log and analysis environment. And with a lot of legacy system, there's text logs, but you have to go on the production servers to get access to those logs. You want to redirect those logs to an offline system. Application Insights, Splunk, New Relic, Stackify. There's lots of great products out there that give you that capability. And then you're going to realize that, oh, we never had enough logs. We never had everything that we needed. So you need to augment and add more telemetry. And then you want to, here's the hard one, then you need to bite the bullet and recreate a new server environment. You need to prove to yourself that you can recreate a production environment. If you can't, you are one step away from an outage turning into a disaster. And that's going to force, just recreating this environment is going to force the learning of your team that's required to automate environment recreating, which is a big piece of automated DevOps pipeline. So again, our goal is to regain control over our system so that we can make the needed changes as we move along our chosen modernization strategy. Now, the perceived easy way out of a system that's hard to change is to avoid it and then say, oh, let's just replace this. Let's build something new, build something up next to it. And then, oh yeah, we'll just do a data migration and cut over. Bing, bang, bada boom. It's going to be easy, right? But facing the storm gets you there quicker. Let me tell you about the difference between Buffalo. We are almost finished, and I'm sorry about these technical difficulties, but I want to tell you about the cow versus the buffalo. And as I'm sitting in front of my computer, it is totally frozen up, but that's fine because there was only one more closing slide. So I'll just roll with it. But you need to know about the cow and the buffalo. There are cattle and there are herds of buffalo in the Midwest, east of the Rocky Mountains. And when a storm comes from the west, which it typically does, the cows see it coming and they start walking east because they don't want to go in the storm. So they start walking away from the storm. And ultimately they get to a barbed wire fence at somewhere on the range and they have to stop because they can't go any further. And so the storm overtakes them and they get soaked, right? The buffalo, they see the storm, they start walking west. They start walking into the storm. Now the storm gets to them, they still get soaked. They arrive at the storm first. But the difference in their mentality, they get through the storm faster than the cows do because they are walking into it. They are facing the storm. And so it's inevitable. This is going to have to be dealt with. So be the buffalo. Don't be the cow. Even if you've been avoiding dealing with your legacy system for some time, turn and face it now. And even if your plan is to replace it with a new custom developed system or replace it with a package, you will have to do an incremental chunking of some sort. You can't do that big bang cutover. So you have to have your legacy system in at least a basic sense of control where you can revise and refactor and redeploy it. And so these are the techniques to think about as we go through. And so even with the technical difficulty, I apologize for that. I hope this was beneficial. And Heather is putting my email address in the chat window. You can reach out. I'm at Jeffrey Palermo on Twitter as well, JEFFREYPALERMO. I love helping people talking about this. And as a software architecture firm, our goal is to empower your software development team. We empower software delivery. Our goal for you is to have a higher level capability to move faster, deliver quality, run your systems with confidence, and be more self-sufficient internally. So that's our goal. Whether you come to all of our webinars every single week, or whether we actually do an architecture project with you, reach out. We love all of you who are part of our community, and I hope this webinar was useful to you. And I believe that, at least before it froze, I had kind of worked in all of the questions that had come through as I was going through. I can't really tell if there's any new questions that have come about. But if you have any questions whatsoever after this, just reach out directly. I mean, I love getting on phone calls with people and just talking through this stuff. So anyway, thank you so much for your time, and I hope you all have a great rest of the day. Take care.